So yesterday when we were going over v equals d over t, it was basically just for scalar type problems, okay, where direction didn't matter. Right? Now, this is an example of a similar kind of question, but where direction does matter, because now we're dealing with displacement and velocity rather than distance and speed. Okay? Mathematically, there's only a very small difference. Okay? So really, your biggest challenge when you're reading a question is being able to identify whether you're being asked to do a scalar question or a vector question. All right? The easiest way to do that is to look for A, the key words that say find velocity. Well, and remember that velocity is vector. Or look for anything in the question that actually denotes a specific direction, like up or down or right or left or north or south. Okay, something like that that says, hey, it's actually going this way. Okay, if you see that in there, chances are you're going to have to solve it as a vector problem. Okay, the biggest and best way to figure out whether it's a vector question or not is to look at what does it specifically ask me for. Does it ask for velocity? If it's asking for velocity, I have to do it as a vector question. Everybody with me there? So we really do have to memorize, unfortunately, okay, that speed is scalar and that velocity is vector and that distance is scalar and displacement is vector, which is just something we have to remember so that we solve problems correctly. All right, so in this question here, we have a bus that goes 100 kilometers north in 1.2 hours, and then it turns and travels 62 kilometers south in 0.9 hours. What is the average velocity of the bus? Okay, so it says here straight out, this is a vector question because velocity is being requested. All right, so yesterday when we had a question that had a trip with two parts, how did we start it? Exactly. We wrote down the givens separately. Okay, we said here's the givens for part 1, here's the givens for part 2, and then kind of looked at it in terms of, all right, here's what I need, and here's how I can get it. Okay, so that's how we're going to set it up for this one as well. So my givens for part 1 are that the displacement is 100 kilometers north. Right? And the time is 1.2 hours. Okay, and in part 2, it travels 62 kilometers south in 0.9 hours. All right, so now we've got our givens. The question wants average velocity. Yesterday when we found average speed for a trip with more than one part, we solved it by going total distance divided by total time. Since I said there's essentially not any difference mathematically here, are we going to be looking at total displacement over total time? Yes, we are. That's what velocity is, right? Velocity is displacement over time. When it's average velocity, it's total displacement over total time. All right. Can I find the total displacement for this question? Sure I can. Okay. I went 100 kilometers north, and then I went 62 kilometers south. How far from my starting point do I end up? 38 kilometers north. Okay. Right? Here's how we figured that out. You can, if you're a visual person, you might want to kind of draw it out. Right? So, all right, I went 100 kilometers, and then I turned around from that point, and I came back 62 kilometers. All right, well, if this line's 100 and this line is 62, the difference is 38, and it's 38 north of where I started. Right? You might even want to draw a compass beside it. Okay, it's north of where I started. All right. So average velocity is total displacement over total time. Okay, so we'll have 100 kilometers north plus 62 kilometers south, which is essentially like saying 100 plus negative 62 or 100 minus 62, whichever way makes more sense to you. Okay, and I'm going to divide that by the total time. 1.2 hours plus 0.9 hours. Okay, so my totals here, we just said, are 38 kilometers north, and that's going to be over 2.1 hours. Okay, is this working mathematically a lot like what we did yesterday? Right? The only difference mathematically is that we had to take into account that one was north and one was south. So instead of just adding them all together, we actually had to make one of them negative, or we had to subtract one of them, okay, in order to make that work. Okay. All right. So when I do that, it should be what, 18? Yeah, 18.1. Okay. Now, how do I figure out what my units are? Okay. I divided something that was in kilometers by something that was in hours. So I'm going to get kilometers over hours, or kilometers per hour. Okay, and that makes sense because I was asked to find velocity, and that's one of the things we can use for velocities, kilometers per hour. What else do I need to have on that answer? North, exactly. I've got to have a vector on it because it was a vector quantity. Okay, so 18.1 kilometers per hour north. And you would have to have all of that on your answer in order to get full marks. Okay, got to have units, got to have direction on a vector quantity. Okay, questions on how that one worked? Okay. Now, that one's fairly straightforward in that, you know, we were given d and t for both parts. Okay, it would be very easy to, instead of giving you distance for part one, I could have given you the velocity in part one. Then you would have had to calculate the distance before you could have done this step here. And we did a few like that yesterday with scalar stuff. All right, I'm going to give you guys a couple minutes to try this one. Very much like the one we just did. Okay, just a different context. Okay, instead of a bus, it's an elevator. All right, so I'm going to give you a couple minutes to try that one, and then we'll go through it together. All right, let's have a look at this one. So we got an elevator that goes 85 meters up in 30 seconds, and then travels 60 meters down in 20 seconds. All right, first part says, what's the average speed? All right, so the question gave us directions, but the first part asks us for something that's scalar or vector. Scalar. All right, so in that case, does it matter whether it went up or down? It doesn't matter for part A. Does it matter for part B? It does. Okay, and sometimes the question is going to do that just to see if you remember the difference. All right, so for part A, solving for this, okay, average speed is total distance, okay, because we worked on this yesterday, d total, okay, over t total. All right, well, the total distance traveled is 85 plus 60, because it doesn't care what direction it went. All right, so we're looking at 145 meters, okay, and that's going to happen in 50 seconds, right, because that's our total time, 30 plus 20. All right, so when we do that, okay, all right, so we'll have our 145, okay, divided by 50. All right, so we're looking at 2.9 what? Meters per second. Okay, do I need a direction on that? No. All right. So that was part A. That was pretty easy. For part B, also really not much harder. Okay, yes, I've got a part 1 and a part 2, and I should probably write my givens in that way. Okay, part 1, part 2. Okay, and when we're looking at that, part 1's displacement was 85 meters up, and that took place over 30 seconds. Part 2, the displacement was 60? Yeah. 60 meters down, and that took place in 20 seconds. All right, for average velocity, I want total displacement over total time. So what I generally do when I'm dealing with a vector question, since in Science 10 at least, you're always going to have directions that are exactly opposite. Okay, you're never going to have a right angle triangle where you're going to have to do trigonometry. Right? It's always going to be forward, backward, up, down, north, south, east, west, whatever. It's always going to be opposites. I assign one direction a positive value, and I assign a negative value to the other direction. Okay? And then that makes my life easier. So I'm going to say down is negative, just because that sort of makes sense in my mind. All right? Mathematically then, I'm going to have 85 meters plus negative 60 or minus 60. All right? And then I'm going to have the total time on the bottom. That's going to be 30 plus 20. So it's still 50 seconds, same as it was in part A. So my overall displacement is that I wind up 25 meters up of where I started. And I know that because the positive value was given up and my answer comes out as positive. So 25 meters, I'm just going to say positive, over 50 seconds. Well, that's pretty easy math. 25 over 50 tells me that my average velocity is 0.5 meters per second up. Okay, making sense? I mean, they do get a little more complex than that, I'm not going to lie. They do get a little bit more complex than that, but at least initially, this is what we're looking at. Jen, you want to just open the door? I don't think Jake sees me. Okay, try this one. It's got 3 parts. Doesn't really change what you do, you just have to do another step, really. Okay? So I'll give you a few minutes to try that one. Alright, let's have a look at this one. So we got a trip consisting of 3 parts. So the first thing I want to do is write down my givens, part by part. Okay, so in part 1 of the trip, the elements walk for 1.1 hours at a velocity of 3.0 meters per second north. What should I do right now looking at the units for my speed and the units for my time? Or sorry, my units for my velocity and my units for time. Nope, before I do that. I can't do that until I do something with my units. Right, turn the hours to seconds. All right, I cannot use hours and seconds to find D, okay, until the units match. So what I've got to do here is multiply 1.1 hours by 3600 in order to get the proper number of hours in seconds. All right, so we're looking at 3,960 seconds for part 1. All right. For part 2, in the second part of the trip, they walk 7 kilometers south in 1.5 hours. Okay, what should I do with the kilometers? Change it to meters. All right, I've got meters per second here, right? So I might as well have it be in meters so that everything is in meters and seconds. Sometimes on a question, you've just got to decide right at the beginning. I'm going to have my displacements all in meters and my time all in seconds, and I'll change everything else to match. Okay, so our displacement for that part is going to be 7,000 meters south. And our time is 1.5 hours, which I also need to multiply by 3,600 to get it in seconds. There's 5,400 seconds in 1.5 hours. Okay, and then in part 3, they walk at 4.5 meters per second north. For another 2 hours. All right, so in 2 hours, there are 7,200 seconds. What's the overall distance traveled and the average velocity of the elephants? If I'm going to find the overall distance traveled, do I need to know the distance in all 3 parts? Okay, I have the distance in part 2, and I do not have it in the other 2. Can I find it? Yes, I can. All right, so it's going to require manipulating v equals d over t. That's not hard. Okay, I'm going to multiply both sides by t to get d, sorry. All right, so d for this one is going to be 3,960 seconds multiplied by 3 meters per second north. Okay, so I'm actually going to calculate the displacement, which is okay, because I'm going to need it later. All right, all I'm going to do when I calculate the distance is forget about what? Not the units, the direction. Yeah. All right, so 3,960 times 3, okay, gives me that they're going to walk 11,880 meters north. Okay, so I've got that now. I already have D and T in part 2, so I don't have to do anything there. But I have to do the same calculation here in part 3 in order to get D. So D equals V times T. That'll be 4.5 times 7,200. Okay. 32,400. Which direction? North. All right, so now I've got D and T for all 3 parts, which is good. That'll help me get both the total distance traveled as well as later calculate the average velocity. So let's do part A first. We want to find the overall distance traveled. Well, the overall distance traveled does not care which direction they went. So all I have to do is add the displacements from each section regardless of which direction they went. So I'll have my 11,000, so D total. And notice I did not put an arrow over this D because it's distance. Equals 11,880. 880 plus 7,000 plus 32,400. So 51,280 meters. That'd be a long day for you or I, okay, to walk 51.28 kilometers. Okay? If you're an elephant, I don't know, take bigger steps, I guess. All right, so that's how far they went in total. Now I need to calculate the total, or the average velocity, sorry, which I already have the answer for down there. It's okay, we'll do it anyway. So we have to remember, average velocity does care whether you went north or south. So we need total displacement over total time. All right. Now I'm going to add positive and negative values to my displacements. So I've got positive 11,880. I've got negative 7,000 because that was south. And I've got positive 32,400. That is so not where I put my marker. All right, so 11,880 plus negative 7,000, or you could just write minus 7,000, okay, plus 32,400, and now I need the total times, so I got to go back up and look them up. 3,960 seconds plus, we said 5,400 seconds plus 7,200 seconds. How come I didn't make this one here negative? Right, I can't. They're going backwards, but they can't go backwards in time. Okay, everyone follow me there? That's one mistake I do see. People transfer the vector from their vector quantities to time, but remember that time is always scalar. It's always going to be positive because it can't go backwards. All right, so now we'll just punch that into our calculator, okay, and get our total here. So we'll put the top in brackets, 11,880 plus negative 7,000 plus 32,400, and we're going to divide that by the total time, 3,960 plus 5,400 plus 7,200. Okay, so we're getting, did I miss a 0? No? Okay, so it comes out to 2.25 meters per second. It's what? No, that's right, 3,960. Yeah, so it's just, for some reason, it seemed like a small number to me. Okay, anyway, 2.25 meters per second north. Okay, I think I had the answer in kilometers per hour before. I was looking at that number, but it was in kilometers per hour. I think that's why it seemed different to me. So that's the speed at which they walk, right? 2.25 meters per second. Right? That's not terribly fast, but I mean, when you walk the whole day, you can put on a lot of kilometers. All right, everybody follow there? So really, other than that it had a third section, it's really not any different than what we did with the two-part problems. All right. Now, am I going to ask you a question like that on a unit exam? No. Okay, because it takes too long, and you're doing the same thing 6 or 7 times. All right, it doesn't really tell me. I can find out whether you know how to use v equals d over t in a much shorter question. All right, everybody follow me there? Doesn't mean you wouldn't get one like this on a quiz, right? But you probably wouldn't get one on an exam where the use of time is a little bit more important. Okay. All right, I want you working on the back side now of that worksheet. Those are vector questions, so direction now matters on those. All right, answers are on there, so check them as you go, and we'll go through any that give you trouble. Yes. Yep. Okay, so guys, a couple of people have asked questions here about number 6. Number 6 is not one you will ever be asked to do in Science 10. I just put it in there to see if anyone would figure it out. Because you have directions that are not directly opposite to each other. You have south and then east, which makes a right angle triangle. So you would have 2 sides of the triangle, and you might be able to figure out the side that represents the total displacement using some Greek guy's idea. His name started with P. Ah, see, there we go. Like Pythagoras, that guy. You know, the Greek geek who studied triangles his whole life. All right, yeah. So you can use Pythagorean theorem to get that other side. You can use trigonometry, tan, to get the angle. You don't have to do it. I'm never going to ask you to do one like that in Science 10. Okay, Physics 20, second thing you learn. Okay, in Physics 20. But all right, for this course, you don't have to worry about it. So if you want a challenge, try number 6. If you don't want a challenge, you don't have to do number 6. Any of these giving us trouble other than 6 that you'd like to go over? Don't be afraid to ask. Okay, keep her going.